Hello, my name is Andrew Silliphant and I'm a Principal Solutions Manager with Pure Storage. Today I'm going to talk to you about scaling database technologies like MySQL and MariaDB using volume snapshots on FlashArray and replication technologies included within the databases. Replication technologies in these databases allow data to be copied from one instance to another and then be accessed on demand in a number of ways. Databases participating in a replication relationship can sometimes be known as secondaries or primaries. Primary systems accept reads and writes or any changes, while secondary systems typically only accept read operations. However, in multi-primary setups, you can have read or write operations going to multiple members of the replication topology. Replication technologies allow for data to be copied from one instance to another. Once data has been copied from one instance to another, any changes that happen to the original instance or another instance in certain scenarios will be replicated across the entire topology. There are a number of different topology types. One of the most common topology types is to have a primary system and a secondary system. Primary systems accept changes in all their forms as well as new data, while secondary systems typically only allow for data to be read from them. There are also topologies that have multiple primary setups. Multiple primary setups allow for changes to be done to any instance within the replication topology. This is great for scale as well as high availability. And replication topologies are quite flexible, so they can meet a number of needs for businesses. There are many replication technologies available for MySQL and MariaDB. To ensure time remains short and we focus on the most common use ones, we're only going to focus on three. These three are standard replication, group replication, and Galera cluster. Standard replication is typically between one or more MySQL instances. However, there is always a primary MySQL instance, while many secondaries stay in sync with the primary instance through the use of binary log replication or GTID identifier replication. Group replication is a part of InnoDB cluster. InnoDB cluster is made up of three core components. Group replication is one of these three core components. One of the components is MySQL shell, another is group replication, and the final one is a router. Group replication can be implemented in either a multi-primary or single primary mode. What this means is you can have many instances with multiple modes that are part of this entire setup of InnoDB cluster. What will happen is any client connections will be routed from the router through to the relevant access point and whichever member of the replication topology is most relevant. Galera cluster is a multi-primary replication technology. What this means is you will have multiple instances that allow both reads and writes, and every single one is a primary instance. What makes Galera cluster and group replication unique from replication is the automated failover capabilities. What this means is if any one of these primary instances go offline, all of the others will pick up the load. In group replication, if you have a single primary instance, it will promote a secondary to primary in that event of a failover. When creating a replication topology, it's important to know that data needs to be copied from a pre-existing system to an intended secondary or additional primary system. This is true for any one of the replication topologies. For standard replication, we typically use the MySQL dump utility or copying physical files from one instance to another and starting the secondary instance from that state. Group replication uses distributed recovery methods such as MySQL dump, the cloning plugin, or any way in which data can be transferred from one system to another in an automated fashion using the pre-existing supported capabilities. Galera cluster uses state snapshot transfers. This can be done in a number of different ways using MySQL dump, rsync, the cloning plugin, or an external backup utility like Extra Backup. There's something important to note with this. Data needs to be transferred from one location to another. This takes time. For large databases, it can take an incredible amount of time to establish a secondary or additional primary system in any one of these replication topologies. For scenarios like using huge web server farms where you have many systems connected together in a replication topology and many web servers with access being routed to each and every single one based on load, that can take a long time, but it's also really important to note it also limits scaling while you're trying to establish that additional replica. This requirement to have data copied from one system to another prior to the replication topology either having added an additional resource or being created initially has a number of possible limitations when using these tools. The first of these is that transferring large amounts of data to a secondary system will take time. This is a huge issue for multi-terabyte databases. Some techniques also block the donor systems from having any changes made to them. This is a huge problem for big production environments because it could mean the need to scale is limited not by just a single system, but by the system also copying data to it. The third issue is that in heavily loaded environments, some replicas may struggle to keep up with the state of the primary systems, and thus requiring it to constantly be in a reseeding state, limiting the ability to make use of the replica's capabilities. The final issue to take note of is that some initial seeding techniques can only be providing data to a single joiner at a time. This is a huge problem for replication topologies spanning many replicas, because if 4 or 5 replicas go down in 100 node replication environments, you can only seed one of them at a time from a single donor, thus limiting the ability to expand that scale or keep those replicas up to date. There is a solution to these problems. The solution is to use the data services like FlashArray volume snapshots on FlashArray to establish new replicas from primary data. Let's take a look at what that means. If I have a volume that is actually attached to my primary system on FlashArray already, what this means is with a few short clicks, I can go and I can establish a snapshot of the data at a point in time of the primary system. I can then take that snapshot and I can create a new volume or overwrite an existing volume attached to a replica, which could be a secondary or a primary, prior to the required seeding process. And what this means is the data from this volume ends up here in the state required to start using replication and making it a member of the replication topology. However, you are not just limited to using that snapshot to only seed a single replica. That snapshot can be used to seed multiple replicas at a time, thus allowing us to establish very large replication topologies incredibly quickly, just using a basic data service functionality built into every single one of our FlashArray or Cloud Block Store instances. This method of using snapshots can be used for replication, group replication, and Galera cluster, and is an incredibly efficient way of completely eliminating the wait times for the additional replicas to become available. FlashArray volume snapshots really are a fantastic way in which to expand these environments, not only quickly, but also efficiently and cost effectively, because within a single FlashArray, all of these volumes and the snapshots are deduplicated against one another, meaning you only have to provision storage space for a single replica as a part of your capacity planning scenarios. For more information about how FlashArray can make your MySQL or MariaDB environments more efficient, please go to purestorage.com/open source. Thank you for watching.